Hello, good evening everyone. I am Chinmay and this is the demo for one of the projects that I have made. I call it the Natural Language to SQL Engine or NL-SQL Engine. And as the description says, transform plain English into powerful SQL queries instantly. It's not just limited to generating the SQL queries, but it is going to execute that on the database and give you back the responses. For example, let's just start with some default queries that I have given here. Let's start with list all departments with average salary. What does it return? It returns us the departments with their average salary. And it sorted it for us as well. We did not ask it to sort, but it did sorting too. So thanks. We can see data science has the highest average salary, followed by DevOps, then security, then engineering. Then product, and the least paid is human resource. I don't know why this model would do that, but yes, if any HR is watching, then you're great, you rock. Don't go on this data. QAs are the second least paid employee. Again, I won't comment anything about data, but again, if you're a QA, then you rock too. One more thing that I want to show you, if I just keep spamming this button of run query again. I'll do it again, I'll do it again, I'll do it again, I'll do it again, I'll do it again. You see one thing, the time here, the time does not change. Why? Because all this response, this query and everything, whatever you see here was cached. We have made use of caching because we spam this button. All of us do this. We see any UI, we do it multiple times. And there is second thing that I have implemented, that is the rate limiting. I'll come to rate limiting at the end of this video when I'll show the architectural diagram, but rate limiting is also implemented here. The rate is, I think, 10 requests per minute, but which is less, but this is a pilot. We can increase it to. This was regarding our, let's try a different query. Let's say count employees in each department. What does it say? Oh, it gave us the error. So we have logged the execution error as well. So bad SQL grammar, each department, and their average salary. So in backend, this makes use of an LLM. So we have added the security gates in case there is bad response and then in case there are bad query. Uh, we log it, we put it in our databases, and AI responses can be wrong as well. That is one assumption that you have to take. I am going to execute a different command here, which is a little complex when compared to my previous command. Let's see what response it gives us. Okay, let's try another query. Yeah, we get all the engineers whose salary is more than 90,000. Again, no HR here, but please don't mind. Mm, and let's say something else. Let's put something else. Mm, let's say show me all the engineers and the projects they are assigned to. Okay, so I am assigned to 3 different projects. That's why you see my name 3 different times. Correct? Let's okay, projects is a different table. I will come to the table that we have, the tables that we have. So project is a different table. Let's execute this query and see what it returns us. Okay, it returns us this big query and the responses that we have here. Now the issue that we get while building this or integrating this app is the generation of group by statements that is done by this LLM. So LLM is not quite powerful when it comes to using group by statements. We can execute simple group by statements, but explicit group by statements where the output is going to be huge, where the generated query is going to be huge, we will have to manually look for any malformations or any SQL grammar mistakes that is there and handle it accordingly. Let's execute one last query and see what happens. Delete delete all the employees, delete all the employees. Whose name starts with V. Let's see what it says. It says destructive SQL operation not allowed, which is another safety gate that I talked about, that it does not allow us to modify or delete any operations or any transactions from the database. This is just to get the values from our database. Okay. I have already showed you about rate limiting. Now let me walk you through the architectural diagram here. When I told you about rate limiting, we'll come back to it. So there are two types of rate limiting services that we have introduced. One is the app level rate limiter, where it keeps the track of how many times you have spammed the submit button or run query button. I told you about the rate that is 10 every minute, so 10 requests every minute this app can handle, or this is the rate limiting configurations. We can increase it, it's a configurable value. There is a second rate limiter that we have introduced, that is this LLM rate limiter. So there could be a case where this application is deployed on multiple instances and they are pointing to a single API, LLM API. In that case, all these 3-4 instances will be pointing to a single API, and we need to make sure that we do not over trigger the APIs or over consume the APIs. We have added a rate limiting there, that is 25 requests every minute and 300 requests per day, which is less. Again, it is a configurable value that can be increased. Now let's go through this architectural diagram quickly. A standard Java Spring Boot architecture for controller and service. We have a controller that is exposed to an API. We have a controller that goes to cache as well. Cache point that I already showed you. If we try to put the same request again and again, we are going to get back a cached response. Now comes our NL-SQL service. So what this SQL service does, it's a core orchestrator. It will interact with your LLMs. It will get the response, SQL response back from your LLM. It is going to execute it through SQL executor. And there is one more thing about this application that I need to tell you. Any new table that you add into the schema, any new table gets automatically registered. You don't have to do anything, any manual thing to register the table. Just have to create it in database and leave it. All the queries that it does, all the queries that it does, all the queries it is going to create, it is going to take care of the new table that you have added. How does it do it? It does it via a schema service. So schema service will extract all the schema that you have. It is going to fetch it to the LLM, and the queries when they are created is going to take care of the context that your schema provides. Sorry. Then comes our LLM strategy factory. So there are currently two implementations that I've done. One is the Llama integration, and then there is the Groq integration. So Groq in the backend runs a Llama 70 billion versatile model, and Llama integration runs Mistral 7 billion on local, or Phi 3 mini. It's Mistral 7 billion most of the times, Mistral 7 billion one local needs certain computing power. That is not possible. It is not possible to run many things simultaneously and then run the Mistral application on our local. So if you want to try it out, you can do that, but you need to have a good machine. If you don't, you can try the Phi 3 Mini. So that's it from my side. I am going to attach all these documentation, these architectural diagrams in the discussions tab or descriptions tab, whatever it is called. I'm going to attach all this in GitHub links as well and put a post about it on LinkedIn as well. So, you can give it a check. Thank you. Thank you, everyone.